The last special transformation that we're going to look at is what happens when you take any function and do the absolute value of it. Well, absolute value bars make something positive. What's the absolute value of 5? 5. What's the absolute value of negative 2? Positive 2. So when you have the graph of y equals the absolute value of f of x, does it make sense that your entire graph is going to be above the y-axis?
Yes.
So how do we do that? Well, what we're going to do is we're going to graph our original function. So how hard is it to graph y equals 2x plus 3? Not hard. What do you know about it? You know that it has a y-intercept of 3, a slope of 2, so down 2 over 1, up 2 over 1, and there's the graph. The thing that's going to be important when doing the absolute value of this is we're going to want to find this point, the x-intercept. When is it equal to 0? One and a half, or 3 over 2? Negative 3 over 2, sorry. So if we set 2x plus 3 equal to 0, and we solved for that, we'd get that our x-intercept is negative 3 over 2. Now, when we go to graph, so I'm going to label this one as f of x. When I go to graph the absolute value of this function, well, before I said, what happens when you do the absolute value of positive 5? It stays the same. What about the absolute value of positive 2? Stays the same. Whenever you do the absolute value of a positive part, it stays the same. So if we look at our original graph, this is why it was important to find this point, negative 3 over 2 comma 0, because can you see at that point, that's where your y values change from positive to negative. And where our graph was positive, this part stays exactly the same. What's going to happen to your negative values? They're going to get flipped up, and this part of your graph looks like that. And this is the graph of y equals the absolute value of f of x. So as far as steps, or how do you do these? You just take the negative part of your original graph and flip it over the x-axis. Now, this question could have been done using transformations, right? If I actually put f of x into the equation, can you see that the equation of this graph is the absolute value of 2x plus 3? What's your parent function? The absolute value of x. What transformations have happened? What does the 2 do? Multiplies the x by 1/2, a horizontal compression. What does the 3 do? You have to factor it. Good. So then you would have to take the time to factor out the 2. When you take 2 out of 3, what do you get? 3/2. And so do you see the absolute value graph being compressed so it's a little bit steeper than the normal one, and then moved 1.5 to the left? Now, we knew this technique already. I kind of like graphing the inside first and just flipping part up, because it's actually easier. Here's our last example. The graph is given to us. The graph of x times x plus 3 times x minus 2. So can someone tell me the coordinates of these 3 points? 0, 0. Good. How did you know that it was at negative 3? Right, because of this x plus 3. So negative 3 is our x-intercept. And this one will be 2 comma 0. when I want to graph the absolute value of this? Does it make sense that this part stays the same? This part stays the same. This part gets flipped up. And this part gets flipped up. Cool. Excellent. And that's it. Ta ta ta.
So are we done?
Just a second. Got to make sure.
No, we're not done. Thanks, Ken.
No, there we go. There we go. Now we're done.